Hello everyone and welcome to another video for the Google Agent Development Kit for beginners. This is the 7th video. In the 6th video, we looked at how we can deploy AI agents to Google Agent Engine on the Google Cloud platform, which essentially makes it possible for you to use your AI agents in production. In this one, we are going one step ahead. A lot of you have asked how to work with tools or callbacks within AI agents, and in this video, we are going to cover the kind of callbacks that you can use in the AI agents. So let's get started. Well, first thing first, you have to clone the repository in your machine if you have not already done so, but if you have been following the videos, I assume you already have. In the main branch, you will see that we have this folder named 7 agents and callbacks. This is something that you're going to use to essentially copy paste code from. And if I basically coded everything myself in this video is going to be like 3 hours long. We don't really want that. So we're going to copy paste a lot, and I'm going to explain to you bit by bit what the code does and which kind of tools we are really talking about. But we are going to look at 5 different examples in this particular video. And talking about examples, if you look at the README right here, you will see that the first example essentially demonstrates the before agent callback and the after agent callback, which essentially executes even before the AI agent is executed and then after the AI agent has done the execution and you see a response. So we are going to essentially look into how we can have a detailed session logging and also metrics to see how much time it takes for an AI agent to perform something. For the second example, we are going to look at the before model callback to essentially go to exactly the model itself when we send the query from the machine to the large language model, which is, let's say, Google Gemini in this case. And we are going to redact sensitive information in the second example. The third example will look into after model callback, which essentially is triggered after we have gotten the response from the large language model, for example, Google Gemini, and then performing further actions on it, for example, enhancing the response. In the fourth example, we are going to look at before tool callback. Since our AI agents can use different tools, we are going to look into how we can use the before tool callback to essentially request specifically for dates in a specific format if the user has not provided it. That's going to be really crucial because if you don't have the right input, your tool is going to fail. And finally, in the fifth example, we are going to look into the after tool callback to essentially take the output from the tool and then making it a bit user friendly before it goes out back as an event. Well, having said that, let's actually get into the first example. The first thing that you need to do after you have cloned the repository, you should be able to cd into the folder, which is AI agents Google ADK, and you should be on the main branch. If you do ls, you should be able to see the folder right here, which is agents and callback. But we are not really going to work on this particular branch. We are going to switch to another branch. So you just do git checkout and you're going to say 7-agents-and-callbacks. Once you do so, you are at the right branch to start working. Now what I want you to do is to open this particular project or the GitHub repository into your favorite editor. I'm just going to use nvim in this case. And if I open the file, I can see that in the 7th folder, we have all these folders created. Now, if you open it, you are going to see that we only have the readme.md and the init.py file, but we also have the env files already, at least in my machine, but you might not have them. But if you have followed the previous videos, you might be able to see them as well. But for those of you who have not, I'm still going to show you the env files and the variables that you need. For example, for the first model, this is how it looks. And in this case, the env file has the Google API key, it has the GenAI model, which is Gemini 2.0 Flash, and the Google GenAI use Vertex AI set to false. So just have them in your env file. Now what we are going to do is we are going to go to the GitHub repository and make sure to give this repository a star if you haven't already. And if you are enjoying this tutorial series, that really helps the visibility of the GitHub repo as well. Having said that, if I go inside this particular folder, I should be able to see the agent.python file. And you'll also see the readme here as well. So you can read here or in your editor as well. Well, first of all, I'm going to open this agent.python file in a new tab. And in here, I can see the whole file. Let me quickly walk you through what do we have here. We have a couple of things. We have the imports. Then we have this function called before agent callback. Then we have the after agent callback. And at the bottom, you can see that we have the agent's definition here. So here, the name is Lifecycle Logger agent, has a description that says an agent that logs its interaction lifecycle. The model is Gemini 2.0 Flash. We have the instruction, which just says you are an echo agent, repeat the user's message. And then we have the callbacks. The before agent callback is provided with this property and the after agent callback is provided with this particular property. Now let's have a look at what these do. The first one here is the before agent callback. Now what this uses is something interesting. It uses something called callback context. If you go to the documentation of state in the agent development kit, you will see that we have something called callback context or tool context in this case. When we are managing our state, the best way of sending a new state state or creating a new state is to use something called append message, which is the standard way that you will find here. So we need to do something called event actions.state delta. That is actually dispatching an event within this lifecycle of the agent app, and that would make the change in the state itself. Now this automatically happens when you have an LLM agent and you have an output key. What ADK does behind the scenes is that when a large language model or an LLM agent dispatches an output, it goes via this output key within an event, and that event basically registers in the history and you have the state updated. Well, when it comes to callback context or tool context, we don't have to manually dispatch this particular event. We would have to do it if we are talking about a regular function, but if we are talking about a callback or a tool, we need to take into consideration the callback context or the tool context. And what we do in that case is that we just take the context and then we update the value just like this. There are two things to note here. When you want to get the current state, you do it by saying context.state.get, and then you give it the key that you actually want back, and you can provide a default value here. Once you get the state, you can essentially update the state directly by modifying it. And what the Google ADK does behind the scenes is that it dispatches an event for you. So you don't have to manually dispatch an event. So just to keep this in mind. And if you look at the code that we have right here, it essentially tries to see if the callback context state does not have a session ID, then it just creates a new session ID for us. It uses the UUID function essentially to create a session ID. Then what it does is that it creates an interaction start time. So this whole agent, the example that we have right now, is supposed to have a starting time before agent callback, and then it would look at the end time, or it would go into the after agent callback and see what time is it right now and what is the delta, how many seconds has it been for this whole execution to finish, and that is what we are looking at. So initially we set the date time now in this interaction start time. Then what we do is we get the current request counter because we are going to ask the agent a lot of questions, and every time we ask a question we are going to increase this counter. So we get the latest counter state and then we essentially update the value or the number. So here you can see that we get the recent one and then we add 1 to that, and then essentially we set it back into the request counter. All of this is happening before the agent callback. Then we are logging some things right here, and then after the agent has performed its action, then we essentially go ahead and then we take the start time. So whatever we set before in the before agent callback, which was right here, we essentially get this exact time right here in the after callback. Then what do? We try to calculate the duration. So we basically take a difference of that time. We are looking at the time right now compared to the time that was in the before agent callback. Once we have that, we essentially have the duration, we create a string of it, and then we just print it. That's essentially it. So this whole agent doesn't do much. It essentially just looks at the time and then looks at the duration. So what we are going to do is we're just going to copy this from here, and then we are going to go into our folder here. We're going to create a new agent.python file here. We're going to open it and we're going to paste this just like this, and let's quickly save this. Now what I want to do is I want to go to the folder again and I want to cd into the 7 agents and callbacks, which now essentially has the agent.python file in the correct folder. So if we look at the folder here, we have the example one, which should have the agent Python file. Anyways, we now need to run ADK web right here. And in the meantime, I also want to show you the README as well. So for the example one and the other examples, please look at the README because it's going to be really helpful. It will tell you what am I showing you in this example, what is the purpose, how to basically test it, and what to observe. In this case, you can see that we are looking at the console output after we run the ADK web. So essentially when we send a particular message, what do we need to send, etc, etc. So now that we have the ADK web running, let's go to the browser, and in here I'm going to just quickly go ahead and go to localhost 8000, and now I can essentially pick the first example. Now I'm here. Now what I'm going to do is I'm going to go to state, because you can see all the state variables right here. Now it's nothing. If I go here and say hello, you already know that the agent is just supposed to echo my question back. So if I hit enter, you're going to see that it says hello and then it adds something to the state. You can see that we have the interaction start time here, which goes into the state. It has a request counter that's set to be 1. If I do the same thing again, let's see what happens. If I say hello again, you're going to see that the time changed and the request counter also updated. So we can have something in the state saved for later usage for the agent. So agent can go into the state anytime and then pick a particular variable. And you can also see that we have the session ID mentioned here as well. Really cool. Now let's also have a look at the logs in the console log. So here you're going to see that as soon as I send a question, it essentially comes here and first goes to before agent. It essentially logs the session ID. It says interaction initiated and then shows me the timestamp. And this is exactly what we do right here. So here you can see we have this print statement, which essentially shows us the SID. It also says interaction initiated. And then we also have have here the start time. Afterwards, it essentially makes the API call to the large language model. It essentially sends the system instruction, the contents and the messages that we have, the whole history, etc. Logs any function calls. We don't have any at this moment. And then it comes here in the after agent and you can see the same session ID and then you can see the duration it took. So it compares the start time with the current time in the after agent, basically callback, and then it shows you the duration. So that is one example of how you can use the before agent callback and the after agent callback. Well, great. Now we can look at the second example, which is input sanitization. So if I go here, the second example demonstrates how we can use the before model callback to sanitize user input. In this particular example, if the user tries to send a message that may contain sensitive information, for example, someone says my credit card is this, can you tell me about it? We are going to not send this to the large language model. The agent that we are running is in our control and the data is right there because it's just the framework itself. But the large language model, it could be ChatGPT, it could be Google Gemini, and you may not to send PII information or personal identifier information or identifiable information, whatever that is, to the large language model. So you may want to redact that. And that's exactly what we are trying to do here. So we are going to redact this using the before model callback. Now let's have a look at the agent Python file so we can look at what it does. In this case as well, we essentially have some PII patterns. So we have the credit card pattern right here, which is a regex. We also have the SSN here, which is also a regex. And what we are going to replace the user's input with is this thing. We are going to say redacted PII. Now you can see that here we just have this before model callback and we are using this before model callback right here. So that's exactly what we want to do. Now in this particular function, you can see that we take the large language model's contents and then we look at any message that is from the user itself. Then we go ahead and we parse the user's text and we essentially take the original text and then we sanitize it. You can see that we are trying to look at all the patterns in our regexes right here, which can be seen in this particular dictionary. And then we sanitize the text and then at the end we change the content of the large language model request before it actually goes to the large language model. And that is what we want to do. So I'm going to quickly copy this particular agent and I'm going to go to my code editor and in here I'm going to add a new agent.py file. Let's quickly paste the code right here. And now I'm going to rerun the ADK web so I can also access the second one. And now I'm going to go and refresh here. I'm going to select the second one. And now from the README itself, I can copy an example. So my credit card is this, tell me about it. Now what I'm going to do is I'm going to go here and send this to the large language model. If I send it, you're going to see that here it says, I'm sorry, but I cannot provide any information about your credit card. This is because I'm not authorized to access or store personal information. Additionally, I'm not able to provide financial advice. Now this is the response that I've gotten, but I'm not really interested in response. I'm interested in what did we send to the large language model. And for that, I can just go to the console. So here, if I go a bit up after I initiated my ADK web, here you can see that it says before model, the user's input was this, right? First of all, you should probably also not really log this in the console. That's not really good practice, but this is the sanitized input. Here you can see that my credit card is redacted PII. Can you tell me about it? Now this is before the model request, right? Now we can go ahead and see what went to large language model. So here we have the system instruction, which the ADK web basically creates. Then we have the contents. This is important because this is sent to the large language model. So here you can see that we have my credit card is redacted PII. This is important. So we are not really sending this to the large language model, which is Google Gemini 2.0 Flash. And that's pretty much it. We now are using the before model callback to perform sanitization. Well, that's really cool. Let's actually go to the third example now. The third example is using after model callback to parse the large language model's response for us. And it will enhance the response by adding any helpful content like quick links, etc. that can be sent to the user. And this is really important because after you have received a response from the large language model, and if something is missing or you want to enhance the output before it's shown to the user, this is exactly where you would do it. And we're going to look at this example. So in here, we should be saying, book me a flight from London to Paris. And we can say for this particular date, and the large language model is instructed to make up the flight details in this case. Now let's have a quick look at the agent itself on what it does. So this is my after model callback enhance. And in here, you can see that the large language model or the agent is pretty simple as before. So it has a name, travel response enhancer agent. It has a good description. It uses the model Gemini 2.0 Flash. And now here are the conditions. If the user asks to book a flight, confirm the booking with the made up details, including a flight number. We are saying examples, origin city, destination city, and the date. We are saying if a user asks about policies, provide a general answer. And then we are saying the example of flight booking confirmation is this. Okay, I've booked a flight. This is from London to Paris on this date for you. And then we provide the after model callback right here. Now let's have a look at the function itself. Since we are using the after model callback, we essentially have the LLM response rather than the request. So in this case, we have this LLM response that we can look at. We first do a deep copy of it just for the sake of copying. So we are not really modifying the original response. Then we take the original text from here. Then what we do is we essentially run a regex against the text that we have to extract out details for the flight. And you have the code. You can essentially experiment, try to understand the regex itself. So we're not going too much deep into it, but I'm trying to explain what we are doing. So we try to get a matching flight or the data of the flight itself. And then we try to distinguish different parts of that flight. For example, the origin, the destination. And once we have extracted that information, we set that to the state as we did before. So this is where the state would show up in the ADK web as well, but it's available for the model to use later on as well. Now, once we have that, we essentially print the extracted flight information to the console so we can also see that. If you're not really talking about a flight here, then we might be looking into refund policy or baggage allowance. And in both of those cases, we can provide a refund policy link just like this, or the baggage policy here as well. So this is your chance to essentially take the response from large language model and then add your domain specific information here to show to the user. And if we modify anything in the large language model's response, then essentially we set that in the LLM response. So we update that and then we return it from here. And that's pretty much it. So I'm going to quickly copy this and we are going to try the examples. So let's go to the code. I'm going to quickly go to the example 3. We are going to create agent.py file here, quickly open that and save this. I'm going to quickly go and rerun the ADK web. Let's create some line breaks here. Now I'm going to go here and I'm going to refresh the state here. Now let's quickly go to the example and try out some examples from here. So for example, if I just go and copy this right here, I'm going to actually go and try the third example. And here I can paste this. Now here you can see that it says, okay, I've booked the flight this from London to Paris, etc. But we also have the flight summary as well. This is the flight number. We have from London to Paris and then the date is this. Awesome. If I go to state, I can also see all of these informations because we saved them to the state as well. So flight number, origin, destination, and date, all of them are there as well. Great. Let's try another example. So I'm going to quickly ask about what's the policy for refund. Let's quickly ask this from the agent. And here we expect that we get a link as well. So if I hit enter here, so here we have the response. Here it says our refund policies may depend on specific terms, blah, blah, blah. And then here it says for detailed information regarding your specific booking, please refer to the booking confirmation or contact our customer support team. Well, to be honest, I was expecting this URL to show up, which it did not. So I can maybe ask a follow-up question. Do you have a URL for refund policy I can look at? And let's see if it gives us this time. And actually looking at here, I can see that since we do have refund policy here and not refund policies, that could be an issue. So what I'm going to do is I'm going to actually remove this for the sake of just hacking around it. And let's try this out again. I'm going to go back to my browser and here I'm going to quickly refresh and ask for the link again. And there you go. You can see that we do have the refund policy link right here. If I open it, it essentially is example.com/refunds. Great. And I can also ask about baggage allowance. So I can say, what about baggage allowance? And there you go. You can see that we have the baggage allowance guide and the baggage allowance link. So both of them are here. And this shows you that our AI agent, because of these particular callbacks, is much smarter. All right, let's go to the fourth example here. So in this one, we are essentially looking at the argument validation and modification. In this one, we are going to look at not the agent callback or the model callback, but the tool callback. So when we are trying to use a particular tool, which can be a Python function, we are looking at if the arguments are valid or not. And if not, what do we do from there? So in this particular example, we are going to look at validating tool input. So we are going to see if the tool has the argument for a date in a specific format. If not, it's going to ask the user so we have the right date format. And this would also prevent tool errors. So if the date doesn't exist, the tool doesn't really work and just skips it or asks the question from the user. And in this example, we are going to look at this particular thing or this particular statement. So we are going to say schedule a meeting for this particular thing for the project review with Alice and Bob for the afternoon. So this is sort of a question that we can ask and see if the tool really understands that. Now, before that, I want to open the agent.py file to show you what this looks like. So in this case, we have this schedule meeting tool, and then we have a tool called before tool callback schedule. So in here, you can see that we are using tools and we are passing the schedule meeting tool right here. Then we are saying before tool callback, and we are essentially passing this before tool callback schedule. Now, when you pass the tool callbacks here, you essentially need to also look into which tool was being called. And we do that immediately in here. We are saying if the tool name is schedule meeting tool, which is this function or tool, then we essentially perform all of this. So we're not gonna go into the schedule meeting tool quite a lot, but you can see here it essentially requires a meeting date, the topic, and the attendees, which is a list, and then also a time here as well. And all this basically does is it essentially prints the information and then also returns a message with a success that meeting about this and this has been scheduled. Great. And when we look into the before tool callback schedule, we can see that once it identifies the tool name, it essentially tries to get the meeting date. Then it also parses the time as well. And then it tries to basically look at the format of the date. If it fails for some reason, then it returns an error and says, please provide the meeting date in this particular format, which is essentially going to be sent to the user so they can provide the date in the right format. If there is no meeting date, then it essentially blocks the call. Then if there is an afternoon in the preference, then a time is suggested, which is 2 p.m. If the user says in morning, then the time is set to 10 a.m. So all of these things are basically done there. So I'm going to copy this. Let's quickly go to the code here. I'm going to go to the example 4 here, create an agent.py file there, and then I can paste this. I can quickly save this now, rerun the ADK web. I'm just going to create some line breaks here, and now we can try this. So I'm going to quickly refresh, go to the 4th example here. Now I can just copy this. So I'm just going to copy this statement from here, and this doesn't really have the right date format. So let's copy this. Now I'm going to go here and I'm going to paste it right here, and let's see what this responds. So here you can see that it says, okay, I've rescheduled the meeting for December 25, 2025 with Alice and Bob to discuss the project overview. You can see that here we have the format right. Now let's try something else. Now I'm going to try with the missing date. So let's copy this one, and now we're going to go here and we're going to try this one as well. And now you can see that it asks me if I can provide the date for the meeting. Let's say I go with the date from here. So I'm going to quickly copy this, paste it here, and then see if it works out. Now you can see that it does say it has configured it for me. Now let's quickly have a look at the console itself. So here, if I go up here, you can see that the first call that we did with the wrong format, it goes here, it says before the tool, it's calling this particular tool with original arguments. And here you can see that the date has already been formatted. Now the important thing here is that you can see that the first message had the date in the wrong format, which got fixed, but we do have the afternoon mentioned here, which got changed in the before tool callback, and it says modified the time argument from afternoon to 2 p.m., which essentially is in our code. Now I also want your attention on something here. The first time we sent a message, it basically called the tool, but it modified the date argument itself to format it, and the afternoon got changed to 2 p.m. The second question did not have the date at all. And notice something here. The tool never got called in that case because the tool was skipped because we don't really have the date there. So if you want your tool to skip completely based on certain situations, you can essentially do that within the code or within this particular before tool callback. And you can see that right here in the before tool callback. You can see here, if we don't really have the meeting date provided, then essentially it returns a result from here. And if it does, then it would just skip the tool callback. Otherwise, when it essentially returns none from here, that's when it means that now it can proceed to calling the tool back. But if there is a result returned from here, that means that the tool is going to be skipped and the result from here would be passed to the large language model instead, and the tool will not be called. And that is exactly what we see here. When we provided the date itself, then it went ahead and then it called the tool, and then we got a result back with the particular date, with morning or with 10 a.m. as it says here. Great. Now let's try the other examples as well. So here I'm going to say time preference is going to be afternoon. So I'm quickly going to copy all of this. And if I go to the ADK, paste it, you should be able to see the tool being called as well. And in here you can see 2 p.m. with Dave and Eve for the team lunch. Great. Now let's test the morning as well. This should result in 10 a.m. So I'm going to copy this, quickly paste it here. And you can see here now it says 10 a.m. So it modifies the time according to our code. And finally, a completely valid input. So here let's provide that as well. And here you can see that we have scheduled the meeting for December 28, 2025 at 3 p.m. with Grace and Heidi for the client demo. Now this whole process with the tool callback has enabled us to not have errors at all in the case where the date is missing or the date is in wrong format, because the ADK handles that and basically works for us. That is amazing. And to learn more, I would just say look at the console logs. So for example, in certain cases you will see that when we have the before tool, it's going to call in the case of valid arguments, everything that is supposed to be there, it's all good. If we scroll a bit up, you can see that in the case where we said, for example, afternoon, here you can see that the time argument was changed from afternoon to 2 p.m. So all of that is covered by our tool. All right, now we are going to the fifth example, which is the tool response transformation and caching. In this one, we are essentially using a combination of the before tool callback and the after tool callback. And in this one, we are using the caching mechanism. So what would happen is, before calling the tool itself, we are going to look at if the cache already contains a particular response. If it does, then we use the response right from the cache and we don't call the tool at all. If we don't really have the response in the cache, then we go with the tool's call, and then after the tool callback, we essentially take the raw output from the tool and we save that into the cache for the next time. And this is a currency converter sort of agent, which means that we can have queries that would have the same result. For example, let's say if I'm trying to look into 100 US dollars to euros, then if the same query comes in, there's no point in calculating that again because it's going to be the same. But in the case of real-time conversion rates, sometimes things change quite frequently, and that's why we have an expiry number here as well, or an expiry duration. For testing examples, we are just going to set it for 10 seconds, but you can modify it. So after 10 seconds, if we already have result in cache, but it has expired, then we don't use that cache, and then we actually go to the tool because the cache item has expired. So that's what we are going to do. And in the case of expired cache response, we also remove it from the state as well. And you can see that in the README as well, that we delete the item from the cache via going to the tool context.state, and we are using the key app cache, but essentially you can rename this to whatever you like, but we are saving that in the tool context state. This is the important bit here. Now, as I mentioned, this is a real world example, and this can help with a bunch of things. For example, you can improve efficiency. So if you already have the item in the cache, you don't need to actually call the tool, which is more performant, is faster as well. You also have lesser calls. For example, if your tool calls an API call, then obviously you're saving network bandwidth and also cost in the case of using third-party API. So there are a lot of benefits to that as well. But essentially what we are going to do is we are going to look at the code itself to make you understand what's happening. And this is a bit more complex. I'm not going to cover all of the things, but I'm going to show you like the main parts here. So first of all, here we have mock rates, and in here we are essentially saying what are the rates from USD to euro, euro to USD, etc. So we have a dictionary that we can use here. The cache expiry seconds variable contains the amount of seconds we have for expiry. So this is 10 seconds. So it's going to be really quick for us for testing as well. Then we have the actual tool, the convert currency tool. This essentially takes the amount and basically converts that based on the mock rates that we have right here. And then it returns a dictionary that contains the from currency, to currency, original amount, converted amount, and the rate that we are using. So this is the tool that we have. And now let's have a look at some other functions as well. This is the before tool callback, which is going to be passed to the large language model. And then this is the after tool callback, which is also going to be passed. So if you look at the LLM agent here, you can see that we have the name currency converter agent, the description that essentially tells what it does. Then we have the tools, which contains the convert currency tool. This is the actual tool. And then we are passing the before tool callback and the after tool callback right here. For the model, we are using Gemini 2.0 Flash, just like in the other examples as well. Now let's have a look at what does the before tool callback cache does. Now this is called before the currency tool. So what happens here is that it's first going to identify if we are talking about the convert currency tool, because when we are passing the before tool callback, after tool callback, it can have multiple tools, or we can essentially pass multiple tools here. But since we are only interested in the currency conversion tool, that's why we are using it. So what do we do here? We essentially try to use the tool context right here. Okay. And then we also use a cache key. What we are trying to do here is that we see if it's USD to euro or euro to USD, whatever that is, and we generate a cache key for that. I'm going to show you what it looks like. But essentially there's a key specific to a conversion. So let's say if USD to euro, then it's going to say USD underscore euro with the number and whatever. So if it's the same cache key, then we try to first get it from the state itself. So we look into the state, we say, okay, get the app cache, which is the key that we are using. And inside that, can we get something for this conversion that we are trying to do? Was there a response already in the cache that is not expired? So if we try to get the result from here, and this part doesn't really check if it's expired or not, but it tries to get the particular key. Now, once you have that right here, you essentially can take out information. So first of all, here it looks at the cached entry, it looks at the timestamp right there, and then here we are essentially checking how much time it has been from the last response. So it checks the duration, and then that decides if it expires or not. So here you can see that we are checking if the age second is less than cache expiry, then we use the fresh cache result. Otherwise, we go ahead and we say cache expired for this particular entry, and then we prepare the deletion of the expired entry as well. Now let's talk about what happens after the tool callback. In this particular case, what we do is we again check the tool tool's name. Then we again generate the cache key based on the query, for example, euro to USD or USD to euro with the specific amount. Then we try to get the current app cache, and then we set the new value in the cache key. It contains two important things. One, the date time or the timestamp itself, and then the tool's response, which contains all the values that we saw here, that is from currency to currency, etc. So all of these things could be seen there. Now, once we have the new items for the cache ready, we essentially set that in the state just like this. Then we format the result string as well, just like this. And that's pretty much it. So now I'm going to copy this and we are going to try this out. So I'm going to quickly go to the code here and let's go to the fifth example, create an agent.python file here. And then I'm going to quickly paste it here. Let's quickly run the ADK web again. Now I'm going to go back here and let's quickly go to the fifth tool. I'm going to refresh now. And now let's take an example from here. So let's say if I go and say how much is 100 USD in euro, let's see what happens. So I'm going to quickly open the state here as well. And let's send this a message. Now here you can see that the tool got called and here we got some things in the state as well. We got the timestamp as you can see right here, and we got the response here as well. Now, if we have a look at the tool here, you can see that we say cache debug, cache miss for the key, convert currency tool this. So this is the key that was generated from the function that we looked at earlier. So it's called convert currency tool, then the amount, and then from, and then to. This is the key that we are using. Since there was nothing in the cache, that's what we got. In the after tool, you can see that we have the original tool response for this, and you can see the values right here. Afterwards, you can see that we updated the tool context state app cache to this particular response that you can see right here. And then we have some result formatting, etc. But the main thing is that we updated the cache key in this regard. Now what I'm going to do is add some lines here, and we're going to perform two things really quickly because there's a 10-second cache expiry. So I'm going to ask this one, and then I'm going to ask it again. And every time you can see that the response time gets updated here as well, but maybe not when the cache is being used. So if I go inside the console now, and if I go up to the point where we added some lines, which was right here, you can see that the first time we tried, we essentially would get the same thing. We would get found the entry, which now has an age of 105 seconds. This is the first response that we got, and the expiry was 10 seconds, right? Now this cache expired and we prepared the deletion of the expired entry for this particular thing, right? Because it expired already. Then it calls the tool. How can we see that? If you go a bit down here, and in this case, you can see that we call the tool. So here you can see tool executed, and we get a print from here as well. And then we got the after tool as well. Now this was the second call that we did, and the third call was done immediately after that. So we should have a cache hit in that case. If I scroll a bit down, you're going to see that the last response, which should come from the cache, should have the right logs as well. So here you can see that we have the cache debug, and here it says found entry for the currency converter tool, age 2.78 seconds, and expiry is 10 seconds. So it's actually using the fresh cache result for currency converter tool for this particular key. So it's not really going to the tool in this case. You can see that we no longer have the tool executed log here or the print here, which means that the tool was never called in this case. And then we have the after tool here, and you can see that in this particular example, we don't update the state in this case. We are still using the previous one, which has the 10 seconds expiry. So we are using the same one. So in this case, we don't really update the state. So we don't renew the cache expiry. We just put the result once in the state and then we let it expire. And until that expires, we essentially use the same tool. If you want to reset this information, or if you want to have this logic where every new cached response also extends the cache expiry, you can essentially do that in the code as well. So there's no problem with that. But now, since it should have been much more than 10 seconds, now we should have the expired cache as well. So let's try this again. So I'm going to quickly go here and I'm going to ask it again. In this case, you can see that we had the time updated as well. And if I go to the console, here you can see that we got the cache debug, found entry for this, age was 185 seconds, and cache expired. So it prepared the deletion as well, just like this. And then the tool got executed. This is important. Finally, we also go in the after tool as well. And you can see here we got the updated tool context state. So once we have the cache expired, we essentially update the state from the response that comes back from the tool. That's what we wanted. So this was a really fun example to work with. Let's also try something differently. So what I'm going to do is I'm going to use this particular example now. So let's copy this and I'm going to try to use them pretty quickly. So this is one, and then we also got the other one. And now you can see that we have a cache for a different entry right here. So you can have multiple responses in this dictionary that you can maintain. And now if I go to the console, you can see the exact same thing here. So if I scroll a bit up here, this right here is the actual call. You can see that we say cache miss for the key convert tool. This is 50 GBP to USD. So the tool was called essentially. And then in the after tool, we update updated the context state for that particular key. And then right after that, when we sent another call, you can see in this case, we found the entry for the convert currency tool. So we do have it right here. The age for that response was just 2 seconds and the expiry is 10 seconds. So we used the fresh cache result for this particular key. Then the tool did not get executed and we can see that we did not have to update the response and we essentially just used what we had in the cache. And of course, if you look at the README, it also tells you what to look at, where to look at, so you can experiment with this more to understand how we are using the tool in real world examples. And to be honest, that is pretty much it for this video. I tried to make it concise to not have to code myself along the way because that would make it really long. And I hope that I was able to convey the essence of it and how these callbacks work for tools, for model callbacks, for agent callbacks as well. And now you have actual practical examples in the GitHub repository that you can use. I would highly appreciate if you can give a star to the GitHub repository and like the video if you found this useful. That really helps the channel grow, and also share with others so they can also learn Google ADK for free, experiment, and also give me feedback on what can be improved. And as always, happy coding. I'll see you next time.